Hello everyone. One student sent me the question that we just answered today in class, asking for more explanation about how to calculate the enthalpy of this reaction. The methane, I think, is the substance. It's an organic compound forming carbon tetrafluorocarbon. And we need to do the following. We need to find the enthalpy of this reaction using the given reaction here. Okay, the first thing that we need to do is looking at the product of this reaction and finding one of these reaction here, number 1, 2, and 3, that will match any of these product, right? Because the bottom line is we need to get a overall reaction with combining this reaction, getting the overall reaction. So what I'm going to do is, if I look at the first one, this one is producing hydrogen fluoride. So I'm going to pick that one first, and I will keep the reaction as it is because what I what I want to have is on the product the same hydrogen fluoride that I have on the overall reaction. That's why I don't flip the reaction, keep the same way. The only thing that I will change is the following, because I have 4 mole in the product and I only had 2 mole here, I will multiply the whole equation by 2. By multiplying the whole equation by 2, then I need to change also or multiply the enthalpy by 2, which is 2 times the enthalpy of this reaction. That will be 2 times negative 537. Notice that the value, the sign for the enthalpy remain the same. The second product that we have here is carbon tetrafluoride, and I have here as a product the same compound here, okay? So let me try this one, carbon solid plus 2 fluoride gas forming carbon tetrafluoride. That will be this compound here. And the other thing that I need to keep in mind is because I had 2 mole of the product, I had to also multiply this one by 2. 2 times 2 make 4, and 2. And again, we need to multiply the enthalpy of the reaction by 2. So that will be 2 times the enthalpy of the reaction, and that will be equal to times negative 6080. Last, we need to check the last reaction. The product of this reaction is the reactant here. So the next thing we need to do is flipping the reaction, because I want this organic compound to have on the reactant and not in the product. So flipping that, it will be 624 gas producing 2 carbon solid and 2 hydrogen gas. And notice the following, because this sign here is positive, the enthalpy of the reaction now will be negative 52.3. And now I think we can add all this reaction and see if we can get the overall reaction we have on the problem at the beginning, and that's the one they want us to calculate the enthalpy. The first thing is, now we are going to cancel any element that will be the same on the reactant and in the product by like adding those equations, like an algebraic equation. So I have 2 hydrogen here and 2 hydrogen there. I can cancel them because they are in the opposite side of the chemical reaction. So let me check if I have something else. Yes, I do have the carbon here and this carbon. And that's all that we need to cancel. The next thing is adding them together. So that will be C2H4 gas. And I had 2 fluorine because I multiply those 4 by 2 and 4. That will make 6 fluorine gas producing 4 hydrogen fluoride gas, and 2 carbon tetrafluoride. And this one is matching, even the order is not the same because I just changed the order, but we have this reactant, this is the reactant here. This has another reactant, this is the reactant on my overall reaction. For hydrogen fluoride, I have 4 hydrogen fluoride. 2 carbon tetrafluoride, I have 2 carbon tetrafluoride. Last but not least, we'll be adding all this together. I mean multiplying, and I'm going to use my online calculator for that and see if I can quickly do the calculation. So that will be multiplying 2 times negative 537 plus 2 times negative 680 plus negative, well, actually negative 52.3. And when I do all this calculation, my answer was negative 2024, yeah, 2486.3. And then the unit will be kilojoule, yes, kilojoule. And this answer is matching the one that I have on C. And that was the answer that we go, actually the student who went to the board go on the problem. And that will be my explanation about how to use the less Hess law for solving problems similar to the one that we have on the screen. Hopefully this one will help you, and thank you for watching. Have a good afternoon.